Tonight's video on section 2.7, polynomial and rational inequalities. So basically we're going to work with inequalities that are now polynomial, that have polynomials in them, and also rational expressions. So the first thing when solving something like this right here is you want to get it to be either greater than or less than 0. So we're going to have to move the 15 over. Then we're going to solve the equation as if it was equal to 0. So something like this you're going to factor. So 2 times 15 is 30. The factors of 30 that add to 1 are 6. Factors of negative 30 that add to 1 are 6 and negative 5. So you rewrite the middle term. And then group. So you get 2x, x plus 3, negative 5, x plus 3. So it's 2x minus 5 and x plus 3. So when you set those equal to 0, you get x equals 5 halves and x equals negative 3. These are what are called your boundary points. So basically you're going to make a number line with your boundary points of negative 3 and 5 halves. And now you're going to have 3 intervals. So within the 3 intervals, you're going to test by putting in one number from each interval. So for example, here I choose negative 4. Between negative 3 and 5 halves, I choose 0. After 5 halves, I choose 3, because 3 is bigger than 5 halves. So those 3 numbers I'm going to put into the function to see whether it's positive or negative. So for example, when I put negative 4 into the function, and the function is... Oh, go ahead. Do you need to come in? And the function is 2x squared. It's down here. 2x squared plus x minus 15. So 2 times 16 is 32, minus 4 is 28, minus 15 is 13. So notice it's a positive number. That's all I care about. That's going to be positive there. I'll do the same for 0. Well, 0 is easier. So you have 0 plus 0 minus 15, so it's negative 15. So in this interval, whenever I put a number in, it's negative. And when I put 3 in, well, 3 squared is 9, times 2 is 18, plus 3 is 21, minus 15 is 6. So notice on my intervals here, remember I have this, basically I know any number I put over in that's less than negative 3, it's going to be positive. When it's between negative 3 and 5 halves, it's negative. And when it's greater than 5 halves, it's positive. So now I look at the beginning and I want it to be greater than 0. So if it's greater than 0, that means I want it to be positive. And the intervals where it's positive are less than negative 3 and greater than 5 halves. Those are the intervals where it is positive, and that is your answer. So let's try one more. So we'll subtract 20 from both sides. So until we get it to greater than 0. We factor, so it's x minus 5 and x plus 4. And instead of equal to 0, because we want to find the boundary points. So we get x equals 5 and x equals negative 4. Those are our boundary points. So we draw our number line, and we choose numbers in the interval, like here, negative 5, 0, 6. I substitute it in. So when I put negative 5 in, notice I get 25 plus 5 minus 20, so I get 30 minus 20, which is 10. The big thing is it's positive. When I put 0 in, notice I'm going to get negative 20, so it's negative in that interval. And when I put 6 in, notice you also get 10. So therefore it is positive here. Now if I look at here, it says that I want greater than 0, so that means I'm going to choose the ones where it's positive. So it's less than negative 4 and greater than 5. If it said negative, because it would, if it said less than, then I would use the negative ones between negative 4 and 5. So this is my final answer. So we'll do one here where it's to the third power. So if I subtract, go x to the third plus x squared minus 4x minus 4 is less than or equal to 0. Notice here, to get the critical numbers, I'd group. So I get x squared and then x plus 1 minus 4, so that's x plus 1. Said equals 0, so I get x plus 1 and x squared minus 4. Notice if I factor this, it's x plus 2 and x minus 2. So there are 3 critical numbers or boundary points of negative 1, negative 2, and 2. So when I make my number line, I have negative 2, negative 1, and 2. So if I put in numbers, I put like negative 3. Here I'm going to have to put negative 1, negative 3 halves, or 1 and 1 half, 0, and 3. So if I put in 0, I can already tell you putting in 0 here is going to make it negative. Put in negative 3, so negative 3 to the third plus negative 3 squared minus 4 times negative 3 minus 4. So you get negative 27 plus 9 plus 12 minus 4. So you get negative 18 plus 12 minus 4. Negative 6 minus 4 is negative 10. So it's negative. If I put in negative 3 halves, and I just do it in the calculator, it's going to give me a positive number if I put in negative 3 halves. And if I put in 3 like this, it will also give me a positive number, because 27 plus 9 minus 12 minus 4 would give me 24 minus 4, which would give me 20, and that's positive. So notice it looks like that, and notice since it says less than or equal to, I'm going to look for the negative ones, which are right there. So my final answer is going to be less than or equal to negative 2, because notice it says less than or equal to, and between negative 1 and 2. That's where it's going to be negative. All right, moving right along to rational inequalities. So basically, we'll do the same thing where we have to have it equal to 0. So we're going to move over the 2. It's by subtracting 2 from both sides. Then we're going to set the then we're going to have to basically get a common denominator. So notice we got to get a common denominator. This is x plus 3, so we got to multiply that by x plus 3 as well. And since it's a negative 2 when we distribute, we get negative 2x minus 6, and that's our common denominator. So we combine like terms, and we get negative x minus 5 over x plus 3. And that is greater than or equal to 0. So then it says set the numerator and denominator equal to 0. So if I set the numerator equal to 0, I get x equals negative 5. The denominator equal to 0, I get x equals negative 3. Those are our boundary points. So then I do test intervals again. So negative 6, negative 4, 0. So remember, my expression is negative x minus 5 over x plus 3. If I put negative 6 in, the opposite of negative 6 minus 5 over negative 6 plus 3, I get 6 minus 5, which is 1, over negative 3, so it's a negative number. If I put negative 4 in, I get 4 minus 5, which is negative 9, over negative 1, which is 9. It's a positive number. And if I put 0 in, I get negative 5 over 3, which is negative. So I did the test values, and then basically now I'm going to write the solution set. Well, remember, it's greater than or equal to, so you want it to be positive, which means these numbers. So my answer is going to be between negative 5 and negative 3. Now the reason I put a parenthesis at negative 3 is because remember, negative 3 will make the denominator equal to 0, and that can't happen even though the inequality says that it's greater than or equal to. Because negative 3 would make the denominator equal to 0, you still need a parenthesis. Alright, that concludes tonight's video, and I will see you guys in class tomorrow. Have a good evening.